Hi, my name is Isabela. As a Latina environmental engineer transitioning to data science, I participated in the BIPOC Kaggle X mentorship program. My project goal was to predict tomorrow's rain. I've been to this area in South Florida and noticed firsthand the rainy summer afternoons. I wondered if I could predict that next day rainfall using the current day's rainfall, temperature, wind, surface pressure, and other features. I used machine learning, regression, and classifier models trained and tested on this South Florida 2015 data, and then I tested it on New York City and South Florida 2022 December data. I had to download data from an API and convert the hourly data to daily. This is an example of the vegetation for New York City versus South Florida. Of course, there's more vegetation in South Florida. Here, the precipitation over time for 2015 in South Florida. The winter months are supposed to be the drier season, and yet there was a very big spike in rainfall. I identified this as an outlier, and I standardized features and removed outliers. I now had 87,900 data points. I could now train my models to predict rainfall. The categories I split the data were the 60th percentile and the 95th percentile for the classifiers. Because I chose these percentiles, it creates class imbalance. The last category only represents the 5% maximum of extreme rainfall events. But I did this because I wanted to see how the models could predict those extreme rainfall events. You can see also that the performance for the XGBoost was more accurate on these 2015 South Florida test data, and the neural net regression I chose for all these models without latitude and longitude because the data for New York City had higher latitudes that the model would never have seen, so I thought this was a better option. The XGBoost had these features as top importance, including temperature, current day's rainfall, and surface pressures. In general, the feature importance is like 9% max, so in general, kind of low. The South Florida models were then ready to be tested on 2022 data. Here's the prediction for New York City. You can see the true values are the first two columns, and the predictions are right of the time column. So the neural net regression predicts continuous millimeters of rainfall per day, whereas the categorical predictions group it into the 0, 1, or 2 bins, which indicate small, moderate, or extreme rainfall events. The NNCAT is the regression as a category. Here's the regression. You can see the orange is the prediction, blue is the true value. In general, the extreme rainfall events were kind of badly predicted by the models, but the small rainfall events for New York were well predicted, and the moderate rainfall events for Florida were better predicted than the small rainfall events for Florida, where there's a lot more variability. Now to compare the classifiers. The F1 score is an indicator of accuracy. The color coding used is blue for the first place, second is green, and third place is the orange. So you can see that for each category 0, 1, and 2, each of the models were compared. For XGBoost, there were the greatest number of green and blue, which means it overall did the best of the classifiers. Classifiers are preferred because it's more important for me to know whether the next day's rainfall is small, moderate, or extreme. And also because the regression, you could see, didn't really predict the exact millimeters that well. So the further work could be trying different percentiles to avoid that class imbalance. And also you can add the previous day's rainfall as a prediction variable because from the feature importance chart, the current day's rainfall was high importance, so maybe this would also be high importance. Here's further reading, including some code references, data documentation, and all my code is available on the GitHub link. I want to thank you for watching, and also my mentor and the Kaggle X community for inspiring me to complete the project.